The value of v pounds of a car may be modelled as a continuous variable. At time t years, the rate of decrease of v is directly proportional to v squared. Write down a differential equation satisfied by v. Given that v is 12,000, when t equals 0, show that v equals 12,000 over at plus 1, where a is a constant. The value of the car at the end of 2 years is £9,000. Find the value of the car at the end of 4 years. So let's have a look at this then. So let's look at part A. I've got the question summary here. So write down the differential equation. The rate of decrease, well, the rate of increase is dv by dt, the rate of increase in the cost, the price of the car. Rate of increase of v with respect to t. So the rate of decrease will be minus, and that's proportional, so it equals a constant times v squared, because it's proportional to v squared. So here's the differential equation then. Given that v is 12,000 when t is 0, show that v equals this. So let's do part B now. So separating the variables and integrating gives. So leave the div as is. So we've separated that out. But the v squared we can bring down from times down to divide, can't we? So it's 1 over v squared. The minus I can leave as is. Move the dt up to be with the alpha. Alpha's there. And move the dt up to be with it. So integrate both sides then. This is v to the minus 2, so it's v to the minus 1 over minus 1, but there's already a minus there. So that will just be v to the minus 1 then. Integrate alpha, which is a constant of proportionality, so it's just alpha times t plus k. So 1 over v then. 1 over v is equal to alpha t plus k. So let's move the v up and read from right to left. So v equals, and then move this alpha t plus k down. 1 over alpha t plus k. And here the a value that we've got, alpha, a equals alpha, isn't it? In the solution set here. We've got 1, but we're told here, let's just get rid of that for a moment, because we've got to put in the find the value of k. So v is 12,000 when t is 0. So let's look at that then. So v equals 12,000 when t equals 0 gives. So 12,000 here is equal to 1 over, when t is 0, 1 over k. So that tells us then that move the k up to times the other side and move the 12,000 down. 1 over 12,000, and that's k. So let's put that in then. V is equal to then 1 over alpha t plus 1 over 12,000, which equals, now I'm going to times by 12,000 top and bottom. So on the top I can write the 12,000 which I want, and times by 12,000 on the bottom will give the plus 1, but it will be 12,000 alpha, won't it? 12,000 alpha t plus 1, isn't it? So the a wasn't alpha at all, was it, like I mentioned earlier on? It's actually the a is 12,000 alpha in our expression here. So if we let a equal that, then we can simply write 12,000 over a t plus 1. So v equals, so that's what we wanted to show. And that was part B. So part C now. V is 9,000 after 2 years, find v after 4 years. So when t equals 2, v is equal to, let's have a look again. I think it was 9,000, yeah, 9,000 pounds gives, so we get 9,000 then, is equal to 12,000 over, t is 2, so it's 2a plus 1. This is an object, move this up to there. So 2a plus 1 then will equal, the 12,000 can stay as is, and at the same time let's move the 9,000 from times on that side to divide on the other side. So cancel the 1,000, top and bottom. 12 over 9 is 4 over 3, isn't it? So 2a plus 1 then. Let's move the 1 over. 4 over 3 minus the 1, which equals 4/3 minus 3/3 is 1/3. So at long last then, a is equal to, move the 2 from times down to divide, a is 1 over 6. So v is equal to 12,000 over t over 6 plus 1. So when t is 4 then, when t equals 4, after 4 years, v is equal to 12,000 over 4 over 6 plus 1, which is 12,000 over 2/3 plus 1 is 5/3. 2/3 plus 1 is 5/3. So that's move the 3 up, it's 36,000 over 5, which is 72,000 over 10, isn't it? And that will be £7,200.